Okay, so what we're going to go through next is a more complex shader that is used throughout a lot of different productions. We're going to go about creating a water shader, and I'm going to break this into two separate parts. So the first part, we're going to go over some of the basic components that's required for a water shader. And then the second one, we're going to go over some external effects that you can apply to make your water shader more dynamic and better. So first, what we're gonna do is I've already made like a new little scene, and I've created this. It's like a little pool with a couple rocks, and then I've also applied some rocks underneath, and then I have a flat plane. Something very simple, something just to test out and start off. So what we're gonna first do is I've already brought in a couple textures that I'm gonna be using. Um, these two and actually these three are going to be used for the creation of the water, and then these are going to be used for creating a caustics effect in the second part. So I'll have links to download all three of these, and then we're going to hop into the material folder, and I'm going to create a new master material for water. Essentially speaking, water will be its own section. You will not be really creating um, something to work with water. It's always going to be water or a water type. Like maybe you need a different type of water for like a pond for different colors, or streams or different water effects. So you're going to be working with it a little bit differently. Oh, okay. So now that we have this, I'm going to go in and make some adjustments to our settings. So first and foremost, the water shader is going to be not opaque, but translucent material. We don't need to turn on anything like two-sided. Um, Nothing else here. The big thing is to turn our lighting mode to a surface translucency volume. So it's really great for creating a volumetric effect for things like water. And then I'm going to turn on one more thing, which is screen space reflections. And then our last one is all the way down here. We're going to make an adjustment to our refraction index. So naturally speaking, when you're working with anything like glass or something, index of refraction is the way you refract um, light on a surface. Glass has its own index of refraction number. It's same thing with water. Water's is 1.33. But because we're going to be applying, movable normals and other things, the index refraction is going to be kind of going a little crazy. So your best bet is to apply this normal offset, and it makes adjustments um, with tangent space normals. It's something Unreal Engine created just for this specific reason. If you're going to have like movable normals or like extraneous normals, you don't want to have a crazy amount. So 1.33, that is the scientific number for the refraction point of water. And then what we're first going to do is we're going to go and create some moving normals. So I'm going to go in and I'm going to create, actually, I'm going to bring in our water, actually our water normal. And then you could do this with just a normal texture, or you can do this with what we're going to do approach with world positioning. So we're going to use world position as our way of using for textures, unless you're using a mesh that has a texture set involved. By all means, use it that way. But this will allow you to be able to use any mesh for any reason, and then just apply it and make some adjustments to the world. So we're going to grab our absolute world position, and then we're going to grab a component mask so that we can select the first two channels, which is going to be for our X and our Y for UVs. And then bringing in something like this normal, you want to apply motion to it, because water will always have ripples. It's not always perfectly calm. Especially like in games, you don't want to have calm water. It just looks kind of boring. So we're gonna hit P for panner, And then I'm gonna go in here and I'm gonna make one small adjustment, and I'm just gonna use our speed to be like about 3. And then let's apply our coordinates, and then I'm gonna apply a vector 2. So you can promote this to a parameter if you want to. I don't really want to make too much of a change to this guy as much, so I'm just gonna keep him about the same. So I'm gonna do probably like 17.5 and then maybe like 8.5 or so. And then plug that into our speed. And then I want to be able to make some small adjustments to the amount of speed and panning. So I'm going to apply another multiplier. And this could be our first like parameter, which is our strength for the panning. So we can do this as like um, water normal pan. And then I'm going to default this guy to probably about 0.0305 because you don't want to have like you don't want to go too crazy with it. So I'm going to go in here. We have our water normal plugged in. And then let's test this guy out. So let's plug him into our normal and hit apply. So yeah, be very aware you're going to be dealing with some shader compiling every once in a while. Oh yeah, I forgot. I have not applied our material for him. So I'm going to grab our water. I'm going to create an instance and just going to drag him on top. Let the shaders compile one more time. Yeah, this is just to test out the panning of the normals and see how it looks like with the various values of strength with it. Again, we don't want to have too strong looking normals. Water doesn't look so harsh. It's going to have very subtle amounts. This does look fine. It looks kind of stagnant. Water doesn't just flow in one direction. There's multiple ripples and values and stuff to it. So what we can do is we can actually copy this guy, and then we can paste some more of these values. So I'm gonna grab this guy. Actually, yeah, I'm gonna keep this the same. So we don't want to have one ripple be more than the other, so we're just gonna have this as a single parameter. But here I'm gonna make an adjustment so that it goes into a completely different direction. So I'll probably do like 0.25 and then like -15. At least one negative number in there. You can throw the negative wherever. It's just gonna be so that the normals crisscross. And then what you can do is you can do like a blend. Where is it at? Actually, I'll type in normal. No, not that one. Blend angled correct normals. So you can do this way and apply. And then let's test out and see what everything looks like with it. Compiling again. Okay, so this looks pretty good. We have like our water ripples and everything. It looks good. It looks too strong though. That's going to be one of your biggest issues with this is you don't want to have too much of this like normal highlight on here. It looks like crushing ocean waves. So one thing we can do is, and of course, if you want to, you can apply yet another normal map, maybe like a bigger one to add some ripples, but we're just going to do 2 for now. What you can do is we can the biggest issue you're gonna have is it's this Z looking light stuff is coming from the Z direction because that's where your depth comes from with your normal map. So what we can do is instead of using the Z that's calculated with these normal maps, we can do one thing, which is let's grab some append vectors. And what we're going to do is we're going to take our red and our green channel of both of these guys, because that's where you're going to get that X and Y information, the left and the right motions of the waves. But we're going to adjust the depth. So what you're going to do is you're going to grab those two, you're going to add them together so that we can combine both of the normal information. And then if you want to, you can actually go in here, hit multiply, and then you can even do this right here, this just do like a 0.07. This could be our normal strength value. Like you can always do the flat and normal method, but this is just something very simple instead of needing to use that whole value. And then we're going to use a new node that we haven't really talked about, which is derive normal z. So actually, no, not this one. Where is it at? Function, there we go. So this is a material function that takes your X and your Y information, and then it's going to derive a normalized Z factor from it. So we have these kind of very flat looking values with the two directions. So it's going to give us a different type of a normal map that isn't going to look so strong. It's going to honestly look a lot more natural for water. You can even go about in a different way where you can do a normal blend, and then you can do an append vector and then adjust just the normal. What this is doing is it's taking our normal strength that we already have defined with the two channels, and then it's going to adjust a new Z value. So you now see that we have a lot more of a subtle water on here, and it honestly looks really good. It's subtle. You don't want to have like like a pond or something like that. You don't want to have something so stagnant. And then of course, if you want to, you can do a similar thing. Copy these guys, do another append vector, and then add another version of it, and then do the same thing with this normal derived Z. So what we're gonna do is I'm gonna comment this guy, and this will just be our wave normals. And then let me go into our two parameters that we have, and I'm going to group them for our normal and hit apply. Now, the next thing we need is we need depth. Water naturally has this type of value known as depth to it, where, I mean, naturally speaking, when you look inside like water, it starts getting like darker and darker the further you go down, and that essentially is depth. You want it to be so that the objects are lighter to the top and then darker to the bottom, depending on the actual position. So there's a couple different ways you can apply depth. There's a depth fade node, but we don't need a depth fade node for this. We're going to do our own factor for this. So what we're going to do is I'm going to grab two values, which is our scene depth and then our pixel depth. So what these are doing is they're kind of creating a tangent value that once we put these two together with a divide node, it's going to divide and create a tangent value that slopes when you're at a looking angle. And what it's doing is it's taking your scene data for the depth and then the actual depth of the material, and it creates that tangent. The one thing is that you can do this and you'll have a normal, simple material. This is just an approximation. We need something else. We need to create another tangent. So say this is like a triangle. This will be your like C side, the diagonal side. We need an actual downside. We need an actual amount of depth. So what we can do is we're going to grab another world position node, because we need to actually find like actual position around the world, and then camera position, which is the way we're going to be able to look around and see things. So you do camera position world space, and then we're going to subtract these two values to get a distance. And then we're going to do a small append vector because we're going to, since these are doing world space, so they're going to be 3 different directions. We're going to do a vector 2. I know that's not a vector 2, but we're not going to do anything with the first 2 vectors. We're going to need something just for the z, so our height in a sense. So this will be for our mesh's height, which we're going to be able to adjust. So I'm going to hit a convert parameter, and then this will be our water mesh height, because that always has to be taken into account. And I'm going to default this to value like 60 maybe, which all you need to do is just look at your height of your of the location. So ours is going to be like 77. But you can of course make some small adjustments for cosmetic reasons. So we're going to take these 2 append vectors, and then we're going to do another subtraction. So the first subtraction is going to be with, actually no, I did this wrong. It's not subtracting with the 2. I'm subtracting with the height of the mesh, and then I'm subtracting separately with these 2 values. So I'm creating distance with this one height mesh. So we get camera position with the height of the mesh itself, and then the world position with the height as well. And then we subtract those 2 to get a full height distance. And then what we can do is we'll multiply this value of this depth and then this actual depth, so that we can create a true depth that goes up and down the mesh. So if we want to, we can actually hop in here, and then let's apply to our base color and take a look. And at first is going to show probably like black and white at first, because that's technically what it's creating is a mask. Come on. Oh, it's actually creating world space, but you can actually see we actually have depth in here. So I forgot it's doing 3 values. We need a component mask. So let's hop in here, and then actually I forgot one more thing. I got to do add vector for this guy. So we're going to add that first subtraction of the camera and the world, because you can see like when we're looking at the camera, the offset's like a little weird. It's like really far off in the distance. That's because we need to actually now add this value back to this one, so we can fix that offsetting that comes with it. And then what we'll do is let's add a component mask. And then we're going to grab the B value, because that's the one that we need. Now let's hit save. So now we should be getting like a black and white mask instead of that 3 color value vector thing. Okay. There we go. So you now see that we actually now have depth shown on our objects, but the thing is it stops after a certain amount, because we haven't really defined where that offset distance comes from besides the instance mat that we have. So if we want to, we can actually go into the instance, and then we can go to where that water mesh height is, and then you can actually go in here and adjust where that height is. So here it is perfectly like at 7.7. That's the height mesh itself. If we really want to, that's where you can start offsetting a little bit for depth as well. So now let's go in here, and we can also notice that it's kind of creating the opposite value that we want. We want this to be black and everything else to be white. The depth is supposed to be kind of a black value anyways. So we're going to do a 1 minus to invert the value. And then I'm going to start bringing in a few things to help make some adjustments to so that we can actually control our depth a bit. So we're going to do a divide. This way we can actually make some adjustments on how far the depth will go, like the actual distance of the depth. And then we're going to grab a power node so that we can make adjustments to how contrasted that value is. So let me convert this guy, and this will just be our depth, like offset. Actually, no, let's just do depth. And I'll set like a value, I'll do like a value 50. And then for this guy, this will be our fall off. Depth fall off. And then these guys are going to be like a smaller, just like a 0.1 maybe. And now let's kind of plug it back in here. Okay, so now we have our inverted values. Let's go and take a look at our depth. So you can actually make adjustments to the amount of depth that you're getting. So we can actually see that we're getting this kind of darker value with the depth. Uh, that might look a little too crazy. And then here's our fall off, which you can see that now it's like more of a softer blur. So we're getting our values to really show like depth, like a two-tone depth value. And then of course you can make your adjustments to your height. So now it's back at 77, and then you just adjust your depth just a little bit more. Like that. Because you want to subtly be able to see things like these, like rocks and stuff at the bottom. Because you don't want to see the bottom. You want to be able to see just enough information. So that looks good. So now let's hop back in here, and I'm gonna add one more thing. Because if you notice, you're gonna see that depth is not changing based off of your angle. And naturally, when you look at water, that's not how that works. Water, normally, when you're looking at these kind of viewing angles, you don't see anything. So what we need to do is we need to apply some Fresnel. So let's grab some Fresnel, and then we're going to do a pixel normal, because we're going to need our the normal map not normal map, but like normal mesh information in the world to help figure out the normal information, especially if you're using like a water with that moving normal information. You want to be able to grab that information. And then we might be getting some kind of crazy value, so I'm going to just do a saturate so that this kind of clamps this guy back. Okay. Now we're hitting save. Okay. Now let's see. Probably have to make some small adjustments, but essentially speaking, we're getting to that point where like we get to this vector value and we don't really see as much. Actually, I think I know what it is. We need to apply the depth fade value. So how this guy works is this fade distance is in centimeters. So we want it to be, let's say about like 40 centimeters. Like after that is when the fade starts, the depth fade starts to change. So actually, no, not that. I'm going to multiply that value with it. Okay. Plug in our values. Okay, there we go. So now you have that little distance of depth. Like right at this edge is where the depth starts to go, and then it fades. And then now we're getting like a much stronger depth value. Like, sorry, I have to change my camera speed so it's like 1. It's like when you get to like an extreme value, you don't see as much depth going on. Well, that also does that depth fade thing. If you go in and make some adjustments, it what it's doing is it's applying a small fade so that there's not such a sharp contrast value to your depth too. So now what we'll do is, we already have it in our color. We're going to do this for our opacity because that's how it's going to handle. We want it to be so that the opacity is stronger at the we want it so that the opacity is seen more from the bottom, so we don't see as much. And then at the top, we'll see like actual like the water and stuff at the top. Because in the end, you don't want to see what's ever going on at the bottom. So you, or not as much, but you can actually see the bottom. It's creating you have this weird effect going on right now because of shadows. So let me hit build again. So now that we have a translucent mesh, you're gonna actually be able to see everything. There you go. So now you can actually see because of the mesh and stuff. And then now that we do this, it changes so you don't really see as much. You can of course make some small adjustments like maybe adding in a strength value. That way things can get adjusted, or you can just play around with your depth just a little bit more. So like this, and then from here you can see the depth and stuff. But it's also we don't have any color value technically. We just have this information going on. So what we can do is let's add a lerp, and then we can do two of these like parameter vector colors. So one of these will be our shallow color. And we'll just do like a light color at first. So like I'll do like a baby blue. And then this will be our deep color. And we'll just like this is dark blue. Essentially speaking, water doesn't have too much of a color per se. It's usually what's ever inside of the whatever inside of the of like the water's consistency is what you normally are getting. Water naturally doesn't have like a color; it's reflective and it's translucent. So you usually would have like a darker, almost black color, and that's where you get it. And then it's reflecting like the sky color as well as stuff like algae and other things is like and dirt. That's why some water's like sometimes green or sometimes brown. Okay, and now you can see that we have color, and then you can actually make some adjustments now. So like change our depth fall off so that you don't see as much of things. We'll just try that maybe. Yeah, maybe you want something like that. Again, like I said, water naturally doesn't have that. It's more of a darker color kind of at the top, and then there's like a more subtle color coming like at the bottom. Maybe like this like darkish blue. The Oh, and then another thing also is I forgot to do this in the beginning. Uh, water has there's no change in consistency of it. It's completely smooth. There's nothing that causes a roughness value with water unless there's some type of opaque object above it. So this is going to be another thing why we turned on that screen space reflections value is because naturally speaking with things like this, it's going to take like some reflections of like the sky as like a small sample, or if you have like this reflection capture thing. What this is doing is it's giving us reflections, and then because the refraction from the water, it's making those refractions distort the image a little bit. So you can go about making some small adjustments here and there, but this is essentially some water. Again, in the next one, we're going to go over some other components like foam on the sides, and that's going to be using distance fields, as well as we're going to go over caustics, which caustics is usually handled in a completely different aspect.